In the previous video, we looked at an introduction to radiation. In this video, we're going to try to explain why some isotopes are radioactive and others aren't. So you'll remember that the number of neutrons can vary for an element. Atoms of the same element with different numbers of neutrons, and therefore different masses, are called isotopes. And the example we used in class was carbon. So most carbon on the planet is carbon-12, meaning it has a mass of 12, but we do have some carbon-13 and carbon-14. These are all called isotopes of carbon. Some isotopes are less stable, and the less stable they are, the more likely they are to break down, and this is called radioactive decay. But wait, you might remember from Science 9 that like charges repel, right? Electrons repel electrons and protons repel other protons. So if you think about it, we're saying the nucleus of an atom is filled with protons and neutrons, and those protons repel each other, so why don't nuclei just blow apart? Well, the fact is that there's neutrons there too. And the neutrons act to hold the nucleus together. So we'll try to draw a picture to represent this. So let's say we have a nucleus right here. We've got some protons and some neutrons. Doesn't matter exactly how many you draw, we're just trying to get the point across here. So protons and neutrons, there's our nucleus. We're not going to worry about electrons right here. Now there is this force of repulsion that the protons do repel each other, and so there's this force outwards. We'll call this the force of repulsion. Okay, but at the same time, the neutrons act to hold the protons together and hold the nucleus together, and so there's this inward force as well. This inward force is called the strong nuclear force. And both of these forces are at work, and it's kind of a balancing act between the two. Most of the time, can you guess which force is stronger? Well, most of the time atoms aren't exploding, so the strong nuclear force is usually stronger. However, if it's not, then we get radioactive decay, and either a particle or particles or energy in the form of gamma rays will be emitted. And in the next video, we're going to look at the three types of radioactive decay.